All right, so these two questions are quite a bit easier than the ones we were doing yesterday. Okay, they only involve a change in one type of energy, like they're basically Science 10 questions, okay, where one involves a change in kinetic and the other involves a change in potential energy. Okay, so question number one is about Sisyphus, who's this guy that, well, Zeus kidnapped his wife and then he had the gall to come and try and get her back, so he sentenced him to roll a rock up a hill for all eternity. He was actually in the original Red Bull Gives You Wings commercials, like the very first one, and he was pushing this rock up a hill. Anyway, okay, for the purpose of this question, we know the following things. Okay, we know that the rock is 200 kilograms. All right, and the hill is angled at 18 degrees. And we're looking for how much work he must do in the first 800 meters, okay, of the hill of his sentence. It will increase its vertical height by 247.21 meters in this time. So the height change is going to be 247.21, okay, but the distance over which he rolls the rock is 800 meters. There's actually two ways to do this. One way is really fast and one way is really long and slow. Okay, so hopefully everyone did this just as a work energy theorem problem. All right, so work is going to be the change in mechanical energy, but since I told you at the beginning this thing is moving at a constant velocity, only the potential energy is changing. Okay, so actually we're only looking for work here, so we don't even need the force times distance part. Okay, we just need W equals m times g times h final minus m times g times h initial, because we're only changing the potential energy. So if they have something like givens, give them a mark for that. If they have something along these lines, give them another mark for that. All right, our initial potential energy is at the bottom of the hill, so it's 0. So really all we're left with is this, okay? That work will equal 200 kilograms times 9.81 times 247.21 meters. All right, give them 1 mark for getting the numbers plugged in correctly, and their fourth and final mark will be for the answer. So 200 times 9.81 times 247.21. All right, so we are looking at 4 point, and I think, what do we have here? 2 significant figures? Three significant figures. Okay, so 4.85 times 10 to the 5 joules. Okay, so 1 mark for that answer. Now, the other way that this could have been done would have been to treat it like an inclined plane. Okay, we could draw the internal triangle, okay, and find FG. It would have been 1,962 newtons. We'd have our normal force here. We'd have F parallel. Okay, we could use the 18-degree angle to find F parallel, and then we could multiply F parallel by 800 meters, and we would have got exactly the same answer. It's just a lot more work to do it that way than it is to go m times g times h and be finished. Okay, so on a unit exam, encountering a question like this, do it the short way. Okay, you want to save yourself a little bit of time. All right, questions on number 1. Okay, so if they did do it the other way, if they did it this way with F parallel, those are the steps, give them the marks, and they can get the marks for doing it that way. It just took them longer. All right. In our second question, we have Wile E. Coyote on his rocket-powered roller skates. Okay, we're looking at only a change in kinetic energy in this question. Okay, so work is going to be a change in EK. All right, so we'll give them 1 mark for that and 1 mark for their givens. So we would say like VI equals 0, VF equals 95 meters per second. Mass is 38 kilograms. Okay, so they can have a mark for that. So up to 2 marks. Okay, since he starts at rest, what's his initial kinetic energy? His initial kinetic energy would be 0, right? Because he's at rest. So we are looking for work equals, okay, 1/2 mvf squared minus 0. So we're not even going to bother to write that. So give them a mark if they've got that step. Okay, or maybe they went straight to plugging in the numbers, which would be 1/2 times 38 times 95 squared. Okay, and so we're going to get, what do we have here for phase 2? Okay, so we've got 1.7 times 10 to the 5 joules. Okay, for their fourth and final mark. All right, on this one, that's the only way to do it. I did not give you enough information to find acceleration, find net force, and do it that way. So this was the only way to do it for this one. All right, give them a mark out of 8. Let them see it. Double check that your first and last names are on it. Hand them in right here.